3-3 linearity and continuity of graphs. So I can identify linear and nonlinear functions and continuous and discrete functions. We are looking at standards FIF4 and FIF5. So this section is really all about concepts. There's not going to be a lot of math involved, but we're going to have to know what these terms mean and what they mean on the graph. So discrete function is a function in which the points of the graph are not connected. A continuous function is a function that can be graphed with a line or unbroken curve. Linear forms a line. See how linear has the word line in it? And nonlinear does not form a line. So here are some examples. So we have a discrete function where the points are not connected. So if you look, there's points all over the graph. A continuous function is either a continuous line or a curve. And then neither discrete nor continuous, it's like it has some stuff that are continuous, like you have these two lines. Let me highlight those. So you have these two lines, but they're not connected. So there's a big jump here, which means it's neither. It's not just points in random spots. It's not a curve or a line. It's a line, but it's broken, or a curve that's broken. So the Bargain Book Barn sells young adult novels on a sliding scale. That is, more books you buy, the cheaper they are. The model of the store prices for the given quantities is f of x, discrete or continuous. We need to explain. So here we have number of, let's go back. Here we have number of books down here at the bottom. Can you buy 1.5 books? No, we can't buy 1.5 books. So we'll never have a point here at 1.5. So we're always just going to have points on this that don't really connect because we can only buy whole numbers of books. So that makes this discrete. Okay, so determine whether f of x and g of x are continuous, discrete, or neither. Explain your reasoning. So this one right here, f of x, so this is how we notate it. We say this is f of x. It looks like a continuous line to me. Sorry, I keep hitting that button. So this is continuous. Oh my goodness, I can't spell. Let's try that again. Now over here we have a line. We have lines that are continuous. And we have points, but it's not all connected. So this is not discrete or continuous. It is neither. So as a private investigator, TIA charges $25 per hour for any amount of time up to 8 hours, and then a flat rate of $200 per day, $250 per day. Use the graph to determine if the function that models the situation is discrete, continuous, or neither. So here we do have something that's continuous, but the problem is it jumps all over the place. So this would be neither as well. So filling the pool. If we are filling the pool, and this is our graph from filling the pool, we start out at 0 here, and it looks like we just have a line that continues on. Right there. So I would say this is a continuous graph. Is this a line? Yes, this is a line. So this is also linear. So identify linear functions by graphing. So Martha is driving from Seattle, Washington to Dallas, Texas. She records the distance traveled after the various numbers of hours. So we need to do some math here, and we need to find the difference between each of these things going on. So first things we'll find the difference of is the distance. So I'm going to take 129 and subtract 86 and see what the difference is. So this is 43 miles. And then I want to take 129 and subtract 218. Well, this is 89 miles, and this is 2 up here. So this is 1. So then we go from 5 to 6, which is 1. And then we have 218 minus 261. Which is 43 miles again. And then here we have 3, and that's 261 minus 389. So that's 128. 128, yes. And then we have 1 again, and then there's 0. So if I were to look at this, we have 2 spots here for 89. So I'm going to take 89 and divide it by 2 and see how much it goes up by 1. So that is 44.5. Is that the same as 43? No. So if they don't go up by the exact same interval every time, then it is not linear. So this one is non-linear. Okay, so determine whether y equals 4x squared minus 2x squared plus 3x minus 5 is an equation for a linear or a non-linear function. So the way we're going to do this is we're going to put this equation in to Desmos. So when I put that equation into Desmos, this is what I get. And then I have to ask myself, well, is that linear or non-linear? Well, it looks pretty linear to me because it's a straight line. And there's no curves, bends, or stops. So this is linear. Like I said, this is all conceptual on whether we can determine continuous, discrete, or neither. And then also linear and non-linear. So just to reiterate, linear is a line, non-linear is not a line. Continuous means the graph continues. There's no breaks, jumps. Discrete is just random points on a graph. And neither is going to have a little bit of both continuous and discrete information.